Hello, class. Today we are going to go over section 2.1 algebraic and graphic solutions of linear equations. Okay, so today our objectives are to solve linear equations algebraically, to solve real-world application problems, compare solutions of equations with zeros and x-intercepts of graphs of functions, solve linear equations graphically using the x-intercept and intersection methods, and solve literal equations for a specified variable. Now, we're going to start with linear equations. A linear equation in one variable has the form ax plus b equals 0. A linear equation in two variables has the form ax plus by equals c. Now, we have steps for solving a linear equation in one variable. Step number one is if a linear equation contains fractions, we'll multiply both sides of the equation by a number that will remove all denominators from the equation. If there are two or more fractions, we will use the least common denominator, LCD, of the fractions. We will perform any multiplications or divisions to remove any parentheses or other symbols of grouping for part 2. For part 3, we will perform any additions or subtractions to get all terms containing the variable on one side and all terms on the other side of the equation, all other terms on the other side of the equation by combining like terms. Step 4, we'll divide both sides of the equation by the coefficient of the variable. And step 5, we will check the solution by substitution in the original equation. If a real-world solution is desired, we will check the algebraic solution for reasonableness in the real-world situation. So let's start with an example. First example here says solve for x. We have 2x minus 3 divided by 4 equals x divided by 3 plus 1. Now, we have denominators here, so we want to multiply by the least common denominator here to get rid of those denominators. And that's exactly what we do with our solution here. So we are multiplying everything in this equation by the least common denominator, which in this case is 12, because the two denominators we have are 4 and 3. The least common multiple of 4 and 3 is 12. Now, breaking this down, multiplying 12 on both sides here will cause this 12 and this 4 to cancel down into a 3. It'll cause this 12 and this 3 to cancel down into a 4. And then you'll also have to distribute this 12 to this 1 right here. 12 times 1 is 12, which brings it down to step 2. Next, we'll look at the distribution on the left-hand side with this parentheses. We'll distribute the 3 here to the 2x and the 3 as well to the negative 3. 3 times 2x is 6x. 3 times negative 3 is negative 9. That equals the 4x plus 12 that was on the other side. No change there. Now we need to get our x's together, and we need to get our other terms together. So we will subtract 4x over here. That'll cancel this 4x out, and it'll get our x's together, simplify down to a 2x. And then we will add 9 to the other side as well. 12 plus 9 will give us 21. Now, lastly, we just need to get the variable x by itself, so we will divide by 2. 21 divided by 2 is in of itself 21 over 2. That fraction does not simplify. Now, let's look at this scenario here. It says y over 5 minus 1/2 y over 2 equals 7 over 20. Now, what we want to do first is simplify, okay? We want to remove the parentheses to first find the least common denominator. All right, so what we did here was we simplified this middle term, okay, because there was a simple simplification here that could be done. We can multiply the 1/2 times the y over 2, essentially multiplying 2 times 2 and 1 times y, which simplifies down to a y over 4. This lets us find the least common denominator of the simplified terms. So I'm looking at the least common denominator of 5, 4, and 20. Okay, that's clearly 20. So I'm going to multiply the whole thing by 20 and then break it down and simplify the sides. We're multiplying the whole thing by 20. So we'll have 20 times y over 5 minus y over 4 equals 20 times 7 over 20. Now, the good thing about this is this 20 over 20 cancels itself out. But what we can also see on the left-hand side here is 20 divided by 5 is 4. 20 divided by 4 is 5. So we wind up with 4y minus 5y equals 7. Now we just have to do 4y minus 5y, which is negative y. And negative y equals 7. We need to get y by itself. So I will divide by negative 1. And 7 divided by negative 1 is negative 7. Okay. All right. Now, let's look at this case where we have some decimals here. It says solve for x if y equals 0.72. Well, y equals 1.312x minus 2.56. Okay, first thing we need to do is substitute in the 0.72 for y, which is what we do here. Y, we substitute in the 0.72. We let that equal the equation 1.312x minus 2.56. Okay, we will get our constants together. So get our numbers together here. All we're doing is adding 2.56 on both sides. So you're doing 2.56 plus 0.72. You can use your calculator if you need to solve for that. Okay. Don't expect you to have to add these decimals by hand. Use your calculator. So 2.56 plus 0.72 is going to give us a 3.28 equals 1.312x. I need to get x by itself here. 1.312. I'll divide by it on both sides. And when I do that, you can do that on your calculator. Like I said, you can divide those decimals on your calculator. Do not expect you to have to do that by hand in this class. When I do that here, I get an x equal to 2.5. That's simple. All right, let's look at some applied problems. For applied problems, you must remember to include units of measure with your answer and make sure your answer makes sense in the problem situation. So let's look at this example dealing with credit card debt. It's hard for some people to pay off credit card debt in a reasonable period of time because of high interest rates. The interest paid on a $10,000 debt over 3 years is approximated by y equals 175.393x minus $116.287 when the interest rate is x percent. What is the interest rate if the interest is $1,637.60? All right, so my solution here, first thing I've got is y equals 175.393x minus 116.287. Okay, I got that directly from the problem. It's the equation from the problem itself, right? Now, I need to substitute something in here. I need to substitute in the $1,637.60, which is the interest rate, okay? Note that y, okay, the $1,637.60 is the interest, okay? The interest rate is represented by x. The interest is represented by y. Okay, so I will substitute the $1,637.60 in for your y. And then I'll solve for x to figure out what the interest rate is. That's what we're trying to search for. Okay, what is the interest rate? Okay, when doing this, all I have to do is add over the 116.287 to the other side. Okay. When I do that, I get 1,753.887. Next, I will divide by 175.393 on both sides. This will give me an x of approximately 9.9998. Okay, so the interest rate here, when we have the amount of interest being $1,637.60, the interest rate is approximately 10%. That makes sense. That is a logical answer for credit card debt. The interest rate being about 10%. Sometimes credit cards have much larger interest rates than that, but 10% does make sense in the problem situation. Let's look at the zeros of a function. Any number a for which f of a equals 0 is called a zero of the function f of x. If a is real, a is an x-intercept of the graph of the function. Okay, the following three concepts are numerically the same. The x-intercepts of the graph of y equals f of x, the real zeros of the function f, the real solutions to the equation f of x equals 0. All three the same. So for the function f of x equals 13x minus 39, we want to find f of 3. The 0 of f of x equals 13x minus 39. The x-intercept of the graph, y equals 13x minus 39. And the solution of the equation 13x minus 39 equals 0. All right, let's look at a. If we want to go and find f of 3, essentially all that we are doing here is plugging 3 in for the x in the problem. Okay, so that gives us 13 times 3 minus 39. Okay, 13 times 3 is 39. Okay, this is 39. Basically winds up being 39 minus 39, which is indeed 0. Okay, so we've solved a. The answer to a is 0. Okay, f of 3 is 0. Let's find f of x equals 0, or sorry, f of x equals 0 when x is 3 is the solution to b. Let's see how they come up with that. Okay, so it says we want to find the 0 of f of x. Okay, so remember, to find the 0, what we are doing here is we are letting it equal 0. Then we're figuring out what the x needs to be to make it be 0. Okay, so if I back solve this for x, basically I'm going to get 39 equals 13x and then divide by 13. I see that the 0 here is x equals 3. So f of x equals 0 when x equals 3. Okay, this is the 0 of f of x. Okay, it's that simple. Basically gives you the coordinate point 3, 0. That is the 0. That is where it hits the x-axis. Okay. All right, now let's find the x-intercept of the graph of y equals 13x minus 39. Well, in order to find the x-intercept, if we were algebraically doing it, we would let y equal 0. Well, we just solved that. That was x equals 3. If you graph this function, you can see, hey, it hits the 0, or it hits the x graph right here at 3, 0. You can also find the solution to the equation 13x minus 39 equals 0 by solving for x, which we've done. Hopefully you can see that'll also come out to 3. Four really, really similar questions, basically kind of asking the same thing. You all wind up in the same location. Let's solve a linear equation using the x-intercept method with graphing utilities. The first thing we want to do is rewrite the equation to be solved with 0 and nothing else on one side of the equation. Then we want to enter the non-zero side of the equation found in the previous step in the equation editor of your graphing utility and graph the line in an appropriate viewing window. Be certain you can see the line cross the horizontal axis on your graph. Find the x-intercept by using the 0 command by pressing second trace, the x-intercept of the value of x that makes the equation equal to 0. So it is the solution to the equation. The value of x displayed by this method is sometimes a decimal approximation of the exact solution rather than the exact solution. Note, using the frac command after pressing math will often convert a decimal solution of a linear equation approximated on display to an exact solution. So let's solve 2x minus 3 divided by 4 equals x over 3 plus 1 for x using the x-intercept method. The first thing we're going to have to do if we decide to use the x-intercept method instead of solving by hand is we are going to have to rewrite the equation with a 0 on one side, which means we need to get everything over to the other side. Okay, so what we start out doing here is basically we want to get a 0 on this side, so we need to move this one over there. The easiest way to do that is just subtract it over. Okay, and that's all we've done here. We get 0 equals x over 3 plus 1 minus 2x, minus 2x minus 3 over 4. Okay, now what we're going to do is we're going to enter the right side of the equation in the equation editor of your graphing utility. You should get a line that looks like this. All right, now here's what I'm going to do. I'm going to close my PowerPoint real quick, and I'm going to pull up my TI. Okay, and then I'm going to enter in on my TI that equation from the PowerPoint. Okay, the 2x the x over 3 plus 1. Okay, so I'm going to do alpha f1 so I can put it into fraction form. X over 3 plus 1 minus, going to pull up another fraction here for my next set of fractions. Good thing about YouTube is you can always go back to, if you're confused about how I'm doing these commands, you can pause and rewind and watch the exact buttons that I'm hitting. So I've got a 2x minus 3. I believe it's over 4. That's correct. Okay. Then I'm going to do zoom. I'll typically like to go with a zoom standard, which is number 6. And it's going to graph it on my graphing calculator for me. The biggest thing here is I need to see where it crosses the x-axis. Okay, if you don't feel like you can see where it crosses the x-axis, you might want to zoom out just a bit just to be sure. Okay, if I zoom out here, I can definitely tell where it crosses the x-axis. Now, the next step to finding the 0 here is you're going to hit the second button, and then you're going to hit the trace button. I call it second calc because the blue indicates the blue functions when you press it. Okay, then we're going to calculate the 0. In order to calculate the 0, you have to bound to where it crosses the x-axis on the left. So it says left bound question mark. I'm going to go left to where it crosses the x-axis. I'm going to hit enter. It'll draw you a boundary. I'm going to then use my cursor to go to the right of where it crosses the x-axis. I'm going to give me a right bound and hit enter. And it says guess. So I'm going to guess where it crosses the x-axis, say about right there, and I'm going to hit enter a third time. And then it's going to find the 0 for you here. The 0 is 10.5. That is your answer. 10.5 is your answer. If you do need it to be a fraction, like it said, you can math frac. And sometimes it'll give it to you. If it gives you this error for syntax, it's like, it doesn't like it. Hit second, quit. Go to your blank screen here, and then hit math frac. It'll pull that X answer out, that 10.5, and it'll give it to you as your answer there. If you're a little skeptical about it, hit the X button so that it knows you're indicating the X that you're looking at, and then convert it into a fraction. And that last X that you found for that 0, it'll pull it out, and it'll turn it into a fraction. Okay, you can also turn it back into a decimal if you need it to. Just turn it back into a decimal to 10.5. Okay, let's go back to the PowerPoint. And as you could tell, they have the same answer we do. Now, let's solve a linear equation using the intersection method. So we're going to enter the left-hand side of the equation as y1 and the right-hand side of the equation as y2. We'll graph both of these equations on the window that shows their point of intersection. We'll find the point of intersection with the intersect command after pressing the second trace. This is the point where y1 equals y2. The x value, now the x value is the only thing we care about at this point. The x value of this point is the value of the x that makes the two sides of the equation equal, and so it is the solution to the original equation. Okay. All right. So this one says, in 2017, worldwide digital ad spending reached $227 billion, while TV ad spending stood at $178 billion. The upward trend in digital ad spending for 2017 and projected to 2023 can be modeled by the function y equals 48.953x minus $613.505 billion, where x is the number of years after 2000. To find the year when worldwide digital ad spending is predicted to reach $700 billion, write an equation and solve it using the x-intersect method and the intersection method. Now, I want you to go through for part A and try the x-intercept method on your own. You should be able to figure it out based on that last example. This will give you good practice. I'm going to use the intersection method, so I'm going to go ahead and you can also follow this as well to see that you're doing it right. But I'm going to do the intersection method, the second part, because we hadn't done an example like it quite yet. Now, the intersection method, okay, what the intersection method's basically going to do here is it's going to let one side of the equation be y1 and the other side of the equation be y2, and it's going to find out where they intersect. So in the intersection method, you don't have to move anything within the equation. You set the equation up. Okay, here we know that y needs to be 700. So we'll set our equation to be 700 equals 48.953x minus 613.505. Okay, like I said, you can look at part B here. We're going to let y1 be the equation, 48.953x minus 613.505. And we're going to let y2 be the 700. We're going to graph those, and then we're going to intersect them. See where that intersection point's at. So I'm going to go over here to my graph. I'm going to put both these in. Okay. Clear out that first equation, or that old equation I had in there. Put my first equation in, 48.953 x minus 613.505. Then I'm going to let my y2 be 700. Okay. Yep, I believe that's correct. Yep. And then, okay, if I were to graph these just on the plane that I had started with, it wouldn't show up very well. If I went back and tried to look at them on the standard view, also wouldn't work very well. What I suggest, especially if you can't see it on standard, is to just go ahead and do a zoom fit. If you scroll all the way down, you'll see zoom fit down here at 0. Okay, zoom fit shows both of the lines, and here it does it reasonably well. I can see where they intersect at. That's the important part. So now I'm going to do second trace or second calc. I'm going to run the intersect command, which is number 5. Okay, it's going to ask for the first curve. I'll hit enter. It's going to ask for the second curve, and the cursor is going to jump to the second curve. I'm going to hit enter. And then I'm going to scroll over here, get my cursor close to where that guess point should be where they intersect. I'm going to hit enter again, and it finds it for me. 2.9257071. Okay, so when y is 700, that 700 billion that this problem's talking about, my x has a value of 2.9257071. Okay, so if we go over here, we could tell, like I said, they get the same exact thing that we got. Okay, thus, worldwide digital ad spending is projected to reach 700 billion during the year. Okay, now get this. Well, did they get the same thing we got? Let's see. They say that they got 26.831961. Let's make sure we typed everything in right, because I don't feel like that's what we had. Okay. So if I check this, that's definitely not what we had. Where did our error come in? Mr. Shipes made an error. Oh, can you see the error that I made and the need to go back and check what you enter in? I clearly entered this in wrong. Okay. It was supposed to be 48, not 448. Make sure you enter on your calculator wrong or correctly, and don't make a typo like I did. It's always good to check. Hopefully you were yelling at the screen when I made that error initially. So let's see what I did wrong and see if I correct it. If we'll get the same thing that they do. All right, now we'll graph it. Okay, I definitely can't see where they intersect now, so I'm going to run another zoom fit. Okay. Now, I ran the zoom fit and noticed that it did not show me where they intersected at. So I'm going to run a zoom out. When I run a zoom out, I can now see where they intersect at. I can run the second calc intersect command again. This just shows to show you that Mr. Shipes is not perfect. He can make a mistake. Happens to everybody. All right, run the guess on it, and now we have exactly the same thing the PowerPoint says we're supposed to have, the 26.831961. I thought that first answer looked a little funny. Okay, let's go back to the PowerPoint now. We have the correct answer. We are matching the PowerPoint. Let's get it running. Okay, do notice that this is a real-world problem here, and just because you get an x equal to approximately 27, that might not necessarily be the answer that you're supposed to go with. If you'll notice, in the question, it says that X is the number of years after 2000. So when we find the X to be 27, the actual year that we're talking about here is 2027. Let's keep that in mind. Whew, that was a toughie. All right, let's look at this, some simple interest. And now we're looking at just pretty much letters here. Let's see what's going on. It says the formula for the future value of the investment of P dollars at simple interest R for T years is A equals P times 1 plus RT. Let's solve the formula for R, the interest rate. Okay. Now, we have the formula A equals P times 1 plus RT. Just because it has letters doesn't really change our steps any. We just treat the letters like numbers. Okay. The first thing we need to do is distribute this P throughout this parentheses here. So, step 1, we're distributing the P to the 1 and to the RT. So it simplifies down to A equals P plus PRT. Now, we want to get the R in this case, the interest rate by itself. So the first thing we're doing is subtracting the P over to get that PRT term by itself. Okay. Now, if we want to get the R by itself, we're dividing the the PRT term by PT to cancel out both the P and the T and leave R by itself. And that's what gives us the A minus P over PT as our answer. Okay, so R, which is what we're searching for, equals A minus P over PT. All right, let's try a little harder one here. This one says 2 times 2x minus b equals 5cx over 3. And we want to solve this for x. Now, the tricky part here is x is on both sides of the equations and it's in a fraction. Oh, it's in a fraction. If it's in a fraction, I have something in the denominator. I need to get rid of that part of the denominator first. So I need to multiply this entire thing by 3. If I do that, I'm multiplying this side by 3, but also multiplying this side by 3. This allows this 3 to cancel, and this 3 times this 2 is what gives us this 6. So now I have a more simplified version here. I have 6 times 2x minus b equals 5cx. Well, now I need to distribute this 6 to this parentheses. So 6 times 2x is 12x. 6 times negative b is negative 6b. And that's what equals that 5cx. Okay. Now we want to get the x's together. So what I'm going to do is I'm going to subtract the 5cx over to the left-hand side. But I'm also going to add the 6b over to the right-hand side to go ahead and get that term over there by itself. So all my x's can be together kind of by themselves, my x terms. Now, I can't combine my two x terms because, well, that c is just kind of messing everything up. But what I can do is, because those terms all have x in common that are on that side of the equation, is I can pull an x out of both of those terms. Okay, almost like a reverse distribution method there. When I do that, I'm left with a 12 and a 5c with an x on the outside. Now, if I want to get x by itself, I can simply divide this side by 12 minus 5c, and then this side by 12 minus 5c. Okay, so that shows that in that term. And when we do that, that 12 minus 5c, that whole big term can cancel that whole big term right there out. And we're simply left with x equals 6b over 12 minus 5c. All right. Now, this is writing an equation in functional form and graphing equations. It says to solve the equation 2x minus 3y equals 12 for y, so that it is expressed as a function of x. Then graph the equation on a graphing utility with a standard viewing window. Oh, we need to solve for y. We've done this before. Okay, first thing I'm going to do is subtract 2x over. Okay, that's how I get negative 3y equals negative 2x plus 12. Then I'm going to divide both sides by negative 3. Just keep in mind, when I do this and I go to simplify, I got to put the negative 3 to this term and to this term. Okay, negative 2 divided by negative 3, the two negatives cancel out. I'm left with a positive 2/3 x. And 12 divided by negative 3 is negative 4. Now that I have this term, I can go on my graphing utility and I can graph it. And this is about what your graph should look like. Let's see if we can make our graph look like that. Okay, let's see if Mr. Shipes can type it in correctly this time. Okay, so we got 2x over 3 minus 4. Going to my TI, y equals. Put it in a fraction. So I'm going to go to fraction form here. 2x divided by 3 minus, what are we subtracting there? 4. Try not to type it in wrong this time. Then it does ask us to do it on a standard zoom. So I'm going to go down here and do zoom standard. And if we did it right, which we did, looks exactly like the graph on the PowerPoint. Okay. That completes chapter 2.1. You should be able to do your homework now. If you have any questions, don't hesitate to reach out by email or rewatch the lecture. Make sure you don't do any typos. Let that be a lesson to you. Anybody can mess up and do a typo. Okay. If I can simply do it on my computer, you can simply do it on your calculator. It's always good to go back and check when you're entering in your y equals, just to make sure you're entering in the right thing. Would hate for you to have the complete process correct. You get it wrong.